Alrighty, Algebra 2, welcome back to another thrilling episode of things that I record and tell you about. All right, what we're going to do today is RAT2. I know it sounds funny. We're talking about rational expressions and functions and things like that, but RAT2, adding and subtracting rational expressions guided notes today. We're about to do something that you guys absolutely love and enjoy, and I know that for a fact because you all love fractions. Now instead of numbers, we're going to have polynomials as the fractions in the numerator and denominator. You guys are looking forward to this. Rational expressions are algebraic expressions that can be written as a fraction. The numerator and denominator are polynomials. Here's some fun examples. Here's my favorite, 1 divided by x. You'll see something like that as we keep going along. Another example, how about, I don't know, 5x squared divided by 2x minus 1. There we go. I mean, polynomial on top. It's a monomial, but monomials are still polynomials, right? How about 2x plus 3 divided by 3x cubed minus 7x squared plus 2x minus 1. That's a really bad x. Okay, there we go. There we go. Those are all examples of rational expressions. You've got a polynomial in the numerator and the polynomial in the denominator. One of the big things, just like fractions, what breaks fractions is when their denominator is 0, and the same is true for rational expressions. Our denominators of the fraction cannot be 0. So what happens if we do have zeros in that denominator? It breaks it. So what we have to do is find those, and what we have to do is called exclude those. Those are excluded values. We don't work with those values. So values of a variable then result in a denominator of 0 must be excluded from the domain of the variable, from the set of the variable. We can't use those values because they just don't work. They result in they result in undefined values, so we can't work with that. So here's some examples. How do we determine the excluded values? Well, we do that by finding the zeros of the denominator, the solutions of the denominator, just like we've been doing all year here, right? I've got x plus 2. This is my denominator, right? Below the fraction bar. I've got 2 factors in here. I've got x plus 2. If I set that equal to 0, x equals -2. And the other one, x minus 4 equals 0. X equals +4. My 2 excluded values, my EVs, if you will, are -2 and 4. And again, why are these excluded? Well, let's plug them back into the denominator here. If I plugged 4 in, let's say, I'd have 7, because 4 plus 3 is 7. 4 plus 2 is 6. And then 4 minus 4 is 0. And that's going to cause a problem because you cannot divide by 0. Dividing by 0 is undefined, and that is why we have to exclude those values. So our excluded values, our EVs, are -2 and 4. Let's try this next one here. I've got 4 divided by x times x plus 17. I've got 2 factors in here. One of them is x equals 0. Oh, that's nice because that's already solved. My second one, x plus 17, equals 0. So I would see x is -17, and my 2 excluded values, my EVs, are 0 and -17. Oh, look at that guy right there. Again, we're only looking at the denominator for excluded values. We will simplify later. We'll do some simplifying later. Letter C, because you're gonna try letter D here. Letter C says x minus 1 divided by x squared plus 3x minus 4. And hopefully you're thinking, yay, I get to do factoring, because yay, you get to do factoring. I know, right? What multiplies to -4 but adds to +3? Well, that'd be +4 and -1. Our denominator becomes x plus 4 times x minus 1. And our excluded values there, subtract 4 from both sides or add 1, our excluded values in this case are going to be -4 and 1. With that statement said, why don't you go ahead and try letter D? Try that one out, see what you can come up with, and then we'll come back and check it. All right, as you return, I hope you correctly factored that denominator there. X squared plus 13x plus 42 simplifies to x plus 6 times x plus 7, leaving our excluded values as -6 and -7. So again, that's our first concept. We're going to kind of put that in our back pocket. We're going to need that for a little bit. We'll need it now. We'll need it later. We're also going to need it a little bit even more later. So we'll talk about that as we keep going. But the next thing we're going to do is called simplifying a rational expression. It also might be, in addition to finding excluded values, you might have to do some simplifying, just like we do with fractions, right? We might have to simplify the rational expression. And here's how we do this. What we're going to do is we're going to simplify the common factors. That's a big word in there, factors of the numerator and denominator. Remember, factors are things that are multiplied together. You can't have something that's just like x plus 1 that could be a factor on its own, but the x and 1 aren't factors. The x plus 1 is a factor. Let's take a look at what I'm trying to get at here. For this first one, we're going to simplify the given expression and state the excluded values. What we're going to do is this. We are going to simplify the numerator and simplify the denominator. We're going to find our excluded values, and then we're going to simplify if we can. On this, in the numerator here, I've got 4x plus 4. Well, like with anything we do, we're going to try to take a greatest common factor out. I'm going to have a 4 times x plus 1. That's my new numerator. My denominator is now, x squared minus x minus 2. Well, let's see, what multiplies to -2 but adds to -1? That'd be -2 and +1. So I've got x minus 2 and x plus 1. Oh, I hope you're seeing this right here. Hopefully you're starting to see this. It's at this point before we do any simplifying, we have to make note of what our excluded values are. Our EVs is you just take the denominator. What are the values that the denominator can't be? Well, if x minus 2 equals 0, that x would be 2. I also have if x plus 1 equals 0, x would be -1. And those are the two values that would give us some real problems in the denominator. So we're going to exclude those from our domain set. And now we're going to look to simplify. When we simplify fractions, you have to have a common value on the numerator and the denominator. Like if you've got 4 divided by 16, they can both be divided by 4. And 4 divided by 4 is 1. And just like this, we've got x plus 1 in the numerator and x plus 1 in the denominator. Well, what is x plus 1 divided by x plus 1? We don't cross it out. We don't cancel, right? We use the word simplify. That simplifies to 1. X plus 1 divided by x plus 1 is just 1. So my numerator now, I have 4 times 1, which is 4. And then my denominator, I have x minus 2 times 1, which is just x minus 2. So in here, I've both given the excluded values and simplified. Excluded values and simplified. We're going to do the same thing with B, and then you're going to try out C and D. Again, same thing. We look for a greatest common factor. I've got 7n squared minus 63n. My greatest common factor in the numerator is 7n. I have 7n times n minus 9. My denominator, that's already simplified, right? N minus 9. And it's at this point, I can take my denominator and say, oh, hey, denominator, I have an excluded value. My excluded value is when n equals 9. My excluded value is 9. If I set that equal to 0, that's what would happen. And now I look to simplify. I have n minus 9 divided by n minus 9, which is both 1. So my numerator is 7n times 1, which is 7n, divided by, well, just 1. I mean, I don't need to actually write that 1, right? Because 7n divided by 1 is just 7n. So this rational expression in B simplifies from 7n squared minus 63n divided by n minus 9. That simplifies to 7n with a little knowledge, with a caveat that we have an excluded value at 9. When n is 9, it's an excluded value. All right, with that said, go ahead and give letters C and D a shot, and I will come back and we'll check the work together. All right, as we return, I want to highlight a couple of things in here. For letter C, just remember that's a difference of two squares. If I've got two things that are squared, x squared minus 9 gives me x plus 3 times x minus 3. Or you can think of it as what multiplies to -9 but adds to 0. Well, +3 and -3. You'll notice here that, just as a reminder, before you simplify, you have to find the excluded values, right? Our excluded values are -9 and 3, not just -9. If we would have simplified first, we would have missed that other excluded value. All right, so make sure you've taken care of that. On letter D, we end up with our excluded values of -1 and -8, and this simplifies to 1 divided by x plus 1. Remember, x plus 8 divided by x plus 8 is 1. 1 divided by 1. It's not 0. It doesn't just go away. It's still something there. It simplifies to 1. All right. We've done a couple real important things so far, right? We've taken care of excluded values and what they are. We've taken care of simplifying expressions and how we do that. We're almost to the point where we can do some adding and subtracting. But before we do that, we have to remember some real important things, just like fractions. If we're trying to add and subtract fractions, what do we got to have? Common denominators. Yeah, well done. I heard it. The chair in the back, I think, is the one who said that. But anyway, common denominators. Just like fractions, just like adding or subtracting fractions, we got to have common denominators in our rational expressions. To find the least common denominator, the LCD of rational expressions, we must first factor the denominator and find the LCM, the least common multiple of these factors. Okay, there's a lot of things in here. It's okay. Just listen to the terminology and then we'll see what it looks like, right? To find the LCD of rational expressions, factor each denominator, right? We're just worried about the denominator right now, completely. Write any repeated factors as powers. I'll show you what that looks like. And then we're going to list the different factors. If the denominators have common factors, use the highest power of each common factor. Again, there's a lot of math terms being thrown in there. We know what they all mean, but we need to see what this looks like all put together. Let's go ahead and do this, right? What I'm going to have you do here is also write equivalent expressions. In other words, if I wanted to add or subtract them, I'm going to show you how to get those to be equivalent expressions. Okay, you'll see, right? After finding the LCD, you might have to do some multiplying to make the expressions have the common denominator. We're just going to multiply by a fancy version of 1. All right, we have -2 divided by x minus 5 and 6x divided by x plus 7. Okay, let's see our directions again. Factor each denominator completely. That's already done. Those are already factored. We can't do any more with those denominators. Write any repeated factors as powers. We don't have repeated factors. We need to list the different factors. Well, our two factors are x minus 5. Again, factors are things multiplied together. We have x minus 5 when it comes from here. We also have x plus 7 from our second one, our second rational expression, okay? If the denominators have common factors, use the highest power of each common factor. We didn't have common factors. We just have x minus 5 and x plus 7. In order to get our common denominator, our LCD, we just have to multiply these together. We end up with our LCD being x minus 5 times x plus 7. That's our LCD. That is our LCD, not liquid crystal display. It's not a TV. Our lowest common denominator, least common denominator. In other words, I want to take -2 divided by x minus 5 and make it something x minus 5 divided by x plus 7. Well, how do I do that and not change what the meaning is, right? I'm multiplying by a fancy version of 1. I'm multiplying by x plus 7 divided by x plus 7 because this is just 1, right? This right here, x plus 7 divided by x plus 7 is just 1. I can do that. I can multiply like that all day. Don't forget we get this -2 that's multiplying up here. Right? And if I do that, I can distribute the top. What we're going to do is keep the denominator in that factored form like this. We'll distribute the top, -2x minus 14 divided by x minus 5 times x plus 7. All right, that's our first one. We've written this in what we call, once again, an equivalent expression. Equivalent expression. This right here, negative 2 divided by x minus 5 is the same as negative 2x minus 14 divided by x minus 5 times x plus 7. Those are the same things, technically, right? Let's take this one. We have the 6x divided by x plus 7. Well, I need to also make this x minus 5 times x plus 7. How do I do this? If I multiply the denominator by x minus 5, I also have to multiply the numerator by x minus 5. And what I end up with is 6x squared minus 30x divided by x minus 5 times x plus 7. And I hope what you're seeing right now is, hey, if I needed to, I could add or subtract these two rational expressions because they have a common denominator. We just created the common denominator. I understand. That's a lot. That's all right. That's, we're going to keep working. We'll practice. We'll do all that good stuff. Let's go ahead and do one more together here. Before I let you loose on a couple of your own. Again, we're just trying to get to that add and subtract point, and then we'll do that. We've got negative 14 divided by x squared minus 11x plus 24, and 9 divided by x squared minus 6x plus 9. Again, the first thing we're trying to do is find the LCD, the lowest common denominator, and then we'll write the equivalent expressions. First thing it says factor each denominator completely. Okay, let's take denominator number 1, x squared minus 11x plus 24. I know that negative 3 and negative 8 multiply to positive 24, but add to negative 11. So this first one, I've got x minus 3, x minus 8 from this denominator. And our second denominator, I have x squared minus 6x plus 9. Well, that's an interesting one because negative 3 squared gives me, or negative 3 times negative 3 gives me positive 9 and adds to negative 6. This is like x minus 3 squared. That's that denominator. Well, that's kind of interesting. Let's see what our directions say about that. Let's list our different factors, right? We had x minus 3 here. We have x minus 8 here. We have x minus 3 here, but it's squared. So what do we have to do? If the denominators have common factors, use the highest power of each common factor. Okay, so that's what we got to do. We got to use, because that's got a bigger exponent than this, because that's just 1, right? We need to use x minus 3 squared as our common denominator. So our LCD, if we multiply these things together, we end up with x minus 3 squared times x minus 8. This is our liquid crystal display. Sorry, least common denominator. That's our LCD. Now we got to figure out what do we got to multiply our rational expressions to get that common denominator. Let's take our first one right here. Our first one is, we'll start with negative 14 divided by our factored version, x minus 3 times x minus 8. Well, what do we got to multiply the numerator and denominator to get this to this x minus 3 squared times x minus 8? I've already got one x minus 3 and I've got x minus 8. I have to multiply both the numerator and denominator by x minus 3. And that's what I'm going to do. Because now my numerator becomes, if I'd use the distributive property, negative 14x plus 52. And now we got x minus 3 times x minus 3, which is x minus 3 squared times x plus 8. This right here, this is my equivalent expression right here for the first one. Right here, this is my equivalent expression for here. Now we got to do our second one. I've got 9 divided by what, x, we said that x minus 3 squared. But I need that common denominator. I need that denominator to be x minus 3 squared times x plus 8, which must mean I need to multiply the numerator and denominator by x plus 8 divided by x plus 8. And if I do that and distribute through, I have 9x plus 72 divided by x minus 3 squared times x plus 8. I have two equivalent expressions now. And if I needed to, I could add or subtract them, which we'll do next. Promise, promise. All right, your job right now, take a few minutes and try letters C and D on your own. Do the same steps that we did. All you're trying to do is find the LCD, then write equivalent expressions. We'll do adding and subtracting here in a minute. All right, I'm going to pause. You do your work. Come on back and check. All right, as we return, we look at those first ones. If we look at letter C, my denominator is 4x minus 12, which factors to 4 times x minus 3. And we've got 5 times x minus 3 for the second denominator. So we've got 4, 5, and x minus 3. So we have to multiply those things together. So 4 times 5 times x minus 3 gives us an LCD of 20 times x minus 3. For the first one, we just have to multiply by 5, the numerator and denominator. And then the second rational expression, we have to multiply by 4. Sometimes that's all it takes. Sometimes that's all it takes. For letter D, we have 3 times x plus 4 as our first denominator, and x plus 4 times x plus 5. So if we list out our factors, we have 3, x plus 4, and x plus 5. To get our LCD, we'd multiply those together. In my first rational expression, I just have to multiply the numerator and denominator by x plus 5 because that's what it's missing, to end up with 10x squared plus 50x divided by 3 times x plus 4 times x plus 5. And in my second rational expression, I just have to multiply by 3. That's the only thing that's missing for the LCD to be there for the second one. So multiply the top and bottom, you end up with 15 divided by 3 times x plus 4 times x plus 5. And now here's the thing. If I needed to, I could add or subtract. I'll write that out. I could add or I could subtract. I could add or subtract these two rational expressions. I could do that. I'm not going to, because I got some different ones that I want to do that. I'll show you guys that. We're going to go to the last page of these guided notes, and we are going to do the 3 level we're looking for. It says adding and subtracting rational expressions is just like adding fractions, which you guys love. I know you guys love it. We can do this. Let's go ahead and go. We're going to add or subtract the rational expressions. We're going to identify any excluded values and simplify the answer if necessary. Okay, we're going back to that excluded values thing, so we need to work on that denominator piece, right? Let's look at letter A. Letter A says 5x divided by x plus 6 plus 5 divided by x plus 3. So let's go ahead and, well, these are nice. These are already simplified, right? These are already simplified, both rational expressions, the 5x divided by x plus 6 and 5 divided by x plus 3. That's nice. So let's go ahead. Let's list our denominator factors. I have x plus 6 and I have x plus 3, which can give us our excluded values right away. Our excluded values are going to be -6 from here and -3 from here. Okay. And now our LCD, if we multiply these together, our LCD is going to be just x plus 6 times x plus 3. So in my first rational expression, I've got 5x divided by x plus 6, and I have to get a denominator of x plus 6 times x plus 3. So what do I got to do? I just got to multiply the numerator and denominator by x plus 3. X plus 3, x plus 3. And this is just, again, multiplying by a fancy version of 1. Fancy version of 1. This first expression ends up being, you know what? We'll do that in a second. Plus my second rational expression. Right now I've got 5 divided by x plus 3. And I need to make it look like x plus 6 times x plus 3. So I'm going to multiply the numerator and denominator by x plus 6. So let's go ahead and do that now. Let's move on to this one. 5x times x plus 3. If I distribute through, I've got 5x squared plus 15x. And now that I've got a common denominator, I can just put them all under the same fraction bar. My plus, I've got 5 times x plus 6, so 5x plus 30, all divided by x plus 6 times x plus 3. And now I just got to do some cleanup here, just some simplifying here. I've got 5x squared plus 15x plus 5x plus 30. So we can make that as 5x squared plus 20x plus 30 divided by x plus 6 times x plus 3. This is how you would add those two rational expressions together. We could do some stuff with that top one. 5 plus 40, yeah. I could simplify this top one to 5 times x squared plus 4x plus 6. There's nothing that multiplies to 6 and adds to 4, so there's nothing else that's going to simplify in there. So we're set with this one. I do the things I needed to do. I found the excluded values, found the LCD, multiplied both rational exponents by what they needed, or sorry, rational expressions by what I needed to, and then I added them. I like that a lot. We can do that. All right, for this next one here, for B, it's 6x divided by 12x squared minus 12x minus 5 divided by 2x. So let's go ahead. I'm going to kind of make this box a little smaller here for our final answer. So letter B, I've got 6x divided by 12x squared minus 12x minus 5 divided by 2x. So that second one, that minus 5 divided by 2x, that's already simplified. But that B, that first one here, we got to do some work to this. Let's go ahead and simplify what we can. 6x, let's see, what's my GCF of that? Oh, it looks like 12x times x minus 1 minus 5 divided by 2x. Can we simplify anything here? It does look so. Yeah, we're gonna wait 1 second before I do this. Let's go ahead and do our excluded values. We factored the top and the numerator and the denominator, right? We look at our different excluded values. If I set x equal to 0, okay, so we've got a 0 value here. I've got x equals 1 from here, and I've got 0 again from over here. But that's all right. That doesn't matter. We've got our 3 excluded values. But what I want to do right now, I need to do some simplification here. This one right here, so 6 divided by 12, that just simplifies to 1 divided by 2, and x divided by x simplifies to 1. This first rational expression is 1 divided by 2 times x minus 1 minus 5 divided by 2x. Okay, so now we got that part. We've done all our simplification that we need to. What we need to do now is list out our factors to get our LCD. Well, my factors, things that are multiplying down here are 2, x minus 1. This one's also got a 2. I'm not going to rewrite that. And x, which makes our LCD, if we multiply these things all together, we end up with 2 times x minus 1. This is our LCD right there. 2x times x minus 1. So we need to end up with both rational expressions having denominators of 2x times x minus 1. Let's look at our first one. I've got 1 divided by 2 times x minus 1. The only factor I'm missing there is x. I guess I didn't need to multiply that out, did I? If I would have thought ahead, I could have done that on the top and bottom. Then minus, this is where it's going to get interesting here, minus, I've got 5 divided by 2x. The only thing I'm missing there is multiplying by x minus 1, so I need to multiply the numerator and denominator by x minus 1. All right. And if I do that, this simplifies. Well, 1 times x, as far as I know, is x. Then I've got, again, all divided by 2x times x minus 1, right? Because that's now I've got common denominators. Minus, and I'm subtracting this entire thing. You have to be very careful here. This is where students make the biggest mistake. You need to put this minus, because when I distribute through this as 5x minus 5, that whole thing needs to be in parentheses. I'm subtracting 5x minus 5. I'm not just subtracting 5x and then subtracting 5. I'm subtracting the whole thing. X minus 5x minus 5. And why does that matter? Because if I didn't have that parentheses, you would think this was x minus 5x minus 5, when in reality, it's x minus 5x plus 5 divided by 2x times x minus 1. And when we simplify together, we end up with negative 4x plus 5 divided by 2x times x minus 1. That's the big thing that students forget about. It's the big thing that students forget about. All right, here is your job. You're going to do letters C and D, but you'll notice they're both addition, and that's an accident. Letter D is actually going to be subtraction. Letter D is actually going to be subtraction. 2 divided by 2x squared minus 3 divided by x squared plus 5x plus 4. So your job is to try out letters C and D, and then do what you got to do. Do some practice. Try it out. Work hard. Then when you're not sure, come back and get a little bit of help with it, and we'll go from there. Good luck. All right, so for the penultimate, the ultimate part of this, what we're trying to do in this target, we end up with our first one. If we look at C, our excluded values are 5 and -3. Our LCD is x minus 5 times x plus 3. We end up, we multiply the first rational expression by x plus 3 divided by x plus 3, and the second by x minus 5 divided by x minus 5. We end up adding and combining and all that good stuff, and we end up with 7x plus 5 divided by x minus 5 times x plus 3. For letter D, we end up with our excluded values of 0, -4, and -1. Our LCD ends up being x squared times x plus 4 times x plus 1. So in our first rational expression, we have to multiply the numerator and denominator by x plus 4 times x plus 1. And we have to multiply the numerator and denominator for our second rational expression by x squared. We end up with x squared plus 5x plus 4 minus 3x squared divided by our common denominator. And when we simplify out, we end up with -2x squared plus 5x plus 4 divided by x squared times x plus 4 times x plus 1. Is that a lot of work? Yeah, it is. It's going to take some work and it takes some getting used to. But as long as you follow the steps, follow the ideas that we've generated here, you're going to be just fine. Ask questions, rewatch this video. I got faith in you guys. You guys can do this. Let's knock it out. Take care. Have a fantastic day.